Greatest common factor. Let's start off with defining some terms. If you see this word coefficient, or if I use the word coefficient, remember that that term is talking about the number that is multiplying by a variable. So if we see 3 times xy, then in this case, the 3 is the coefficient, right? The 3 is the number multiplying by the variables. Usually we write those before the variable. We're going to define greatest common factor. Let's break it into parts. Greatest for us, we're just going to say it's the largest. So greatest is the largest. Common is the same. If you have glasses, then you and I have that in common. That's the same for us. Factor. So a factor is simply a number or variable which multiplies by another number or variable to produce another number. I said simply. So think of it this way. Factors are numbers that multiply. So factors multiply. The greatest common factor, we're looking now at our entire term, the combination of numbers and letters, the largest of each, which can be seen to be multiplying by other factors in each term of a polynomial. All right, that's a bit much, but we'll break this down into parts. So our guiding statements, we've got some here to look at. Starting out, very straightforward. 1 is always a factor of a number. That really should probably make sense to everybody. But what that means is that a number is always a factor of itself. 13 is a factor of 13. So 13 times 1 is 13. 25 is a factor of 25. All right, second up, maybe just as simple. All even numbers have a common factor of 2. That's because even numbers can be broken easily or completely into 2 equal groups. So 12 cookies can be split between 2 friends evenly, 6 cookies each. Even numbers end, and maybe this is a little too simple, even numbers end in 0, 2, 4, 6, or 8. So if you see a number that ends in 1, 3, 5, 7, 9, that's odd. And that means that 2 cannot divide evenly out of that number. Therefore, no even number will divide evenly out of an odd number. There are some other rules here, some tips. The thing I would jump to, so 2 and 3 are the most common factors that students want to divide by, or that teachers want students to divide by. And so here's how you test if a number is divisible by 3. Here I'm looking at 702. If I add the digits, 7 hundreds, 0 tens, and 2 ones, add them together and we get 9. If that sum is divisible by 3, 9 is divisible by 3, then the number itself is divisible. And I show you over here that 3, if we multiply it by 234, the result is 702. Your numbers aren't going to be that large. So if you're factoring a problem and you see the number 24, then what you can do is say, okay, 2 plus 4 equals 6. 6 is divisible by 3 evenly. 6 divided by 3 is 2. That means that 24 is divisible by 3. Turns out that's 3 times 8, by the way. All right, there are other steps there, other rules. There's a quick, easy one. If you see a number ending in 0 or 5, that number is divisible by 5. All right. So most students, the issue they have with factoring is that they don't remember a multiplication table. So you're going to have to work through those steps in order to be able to factor numbers. I'm going to try to set everything up at first to be pretty straightforward with which factors you're going to use. We're going to use the same numbers repeatedly. So hopefully that will be a little bit helpful. Okay, some guiding statements for factoring variables. When you look at terms, we need to see the same letter in every term. I've got that written here. If the same letter is in every term, some form of that letter is part of the GCF, the greatest common factor. Now, the next one is the important part. The smallest exponent of each letter in a variable expression is part of the GCF. So let's take 1 minute, maybe less, to talk about that. If I've got 3x squared plus 3x squared y plus 2x to the 5th. So when we look at this, I'm saying we have to see the same letter in both terms. Well, I see that there is an x in both terms. I've got an x squared and I've got an x to the 5th. And so when we write this out in expanded form, this means I have 2 x's multiplying in the first term. I have 5 x's multiplying in the second term. So what is common to of those x's? So the smaller exponent of those two, that's how many of that letter we have in our greatest common factor. So x squared, 2 is the exponent. 2 is less than 5. So that's the smaller exponent. That is how many of those x's we're going to have in our common factor. Notice that the y's, there is a y in the first term, but there's no y in the second term. If we did write a y, we would have to put an exponent of 0. Remember that any number raised to the 0 power is 1, and 1 times 2x to the fifth is 2x to the fifth. So the smallest exponent for y in these terms would be y to the 0. And the smallest exponent for x's would be 2. So the greatest common factor there would have an x squared in it, but no y. All right, finding a greatest common factor. So our steps here, we want to build a list of factors for each coefficient. So we need to list all of the factors. The reason we try to list all of them is because when you have multiple coefficients, you want to be able to easily see all the numbers in the list. And once you pull that greatest common factor out, the other factor from your list of factors is the number that's left. We'll get to that in an example. So we build a list of factors for the coefficient. We determine the largest number that is a factor of each coefficient. So here comes that phrase we saw earlier. We want the largest number that is on all of the lists of factors. At that point, we've factored the coefficients. Now we need to look at variables. And again, we're looking at the smallest exponent for each letter. All right. So how are you going to do this in a problem? We're going to give you a polynomial. I'm going to give you a polynomial. And you're going to determine first the greatest common factor. We just saw how to do that above in this section, right? Now, the key here is this. There's a little star I'm going to put here. If the first term is negative, then we want the greatest common factor to be negative. So when we're looking at our polynomial, if the first term is negative, I'm always going to put a little red star and say, oh, we need to be careful. We need our greatest common factor to be negative. We're going to divide that greatest common factor from each term. And then your result will look something like this. There will be a number or an expression multiplying by multiple terms inside. All right. So it's going to look like the distributive property. And that's really what we're doing. Factoring is undoing that distributive property. Okay. Quick examples here. Notice that we've got our polynomial over here on the left, 12x cubed y to the fourth z minus 6x squared y squared plus 15x to the fourth y cubed z squared. So I pulled the coefficients first. I took the 12, the negative 6, and the 15, and I brought the numbers over here. I didn't bring the signs, and that's just because we're factoring the numbers themselves. The signs aren't super important until later. So we list all the factors of 12. 1 is always a factor. 1 times 12 is 12. 12 is even, so I divided it by 2. 2 times 6. 1 plus 2 equals 3. So that means 3 divides out of 12. 3 times 4. Doing this, following that process over and over. 15, 1 times 15. 15 is odd, so I can't divide by 2. 1 plus 5 is 6, so I divide by 3. We get 3 times 5. The reason I can stop factoring at that point, there's only one number between 3 and 5, and that's 4. But we just showed that because 15 is odd, 4 cannot possibly be a factor. No even number will divide out of 15. So when you write your factors like this, you'll see your factors kind of loop around and go from 1 back to your factor, right? And so maybe that's helpful. Maybe it's not. But we see, I highlighted the wrong one. Would you look at that? So over here, this 5 should not be highlighted. The 3 should be highlighted. I'm going to try to use, look at that. It's almost like it perfectly matches. So we're going to say that is not the GCF. That's not a common factor at all. All right, so 3 is the numeric greatest common factor. The smallest exponent of each variable, we can just look at each term, looking at the x's. We'll start by looking at the x's. So we have x to the third, x squared, and x to the fourth. So the smallest exponent is x squared. For the term with the y's, we look at the terms. We've got 4, y squared. 2 is less than 4. So far It's going to be 2. And then y cubed. 2 is less than 3, so it's going to be y squared. The smallest exponent of y is 2. Now the z's, I've got a z to the first. If you want to write the 1 in there, you can. But z to the first. And then the second term, there's no z. So we can just kind of stop. Because z to the 0, that's going to equal 1, right? Any number raised to the 0 power is 1. So there will be no z in the greatest common factor. And those are the only letters we had, x, y, and z. Notice I wrote the greatest common factor once I found it. That is the number that is outside the set of parentheses. So how do we end up with, inside the parentheses, how do we end up with 4xy squared z? Well, we take each term. So the first term is 12x cubed y to the 4th z. We are dividing that by 3x squared y squared. And so you do 12 divided by 3, that results in 4. And if you remember, we're taking 2 of the x's away from 3, so we will have x to the first power. The y's, we are taking 2 y's out of the 4. By take away, I mean we're dividing. So when you divide variables, we subtract the exponents. 4 minus 2 is 2. And then there is no z to divide out. So we're left with 4xy squared z. So that's how we end up with that term inside the parentheses. All right, that's an example. There are other examples here that you could follow. Notice in example 2, the first term is negative. I wrote the first term of the polynomial. I wrote the negative here in the 30. That's mainly just so that I remember to include the negative as part of the greatest common factor below. So essentially, our goal is that when you look at the polynomial inside the parentheses, that first term will be positive. We don't want to see, a parenthesis and then a negative number. We want to start with a positive number inside the parenthesis. That's why we divide by a negative 6. All right, and again, looking at the terms for the variables, notice that there is an a in both of the terms. The smallest exponent is 1. There is no b in the second term. That's why there is no b in the greatest common factor. And then the smallest exponent, we have c to the first power. So c to the first power is the greatest common factor. And then we divide each term by that negative 6. Be careful with signs. Positive 24 divided by negative 6 results in that negative 4 ac squared. Okay. This video is going to be linked to Schoology. If you have questions, you should definitely message or ask. And we will do lots of practice with greatest common factor. This will be part of the entire unit 2.